Hello everyone, and welcome to the second video in my Practical Python video series. Today we're going to be talking about the very basics, variables and flow control, and a couple other little things. So if you're here, you should have watched the first video. So you have Python installed and Sublime as well. And you should be able to open a new Python file, but in case you need a refresher, just open up Sublime, File, New File, Save As, whatever you want, .py, go here, change it to Python, and hit save. If you find that you're typing and all of your code is just plain white or just all one color or whatever, it's not getting colorized correctly, then that means you did something wrong. It means it's not actually a Python file. So first things first, if you put a hashtag or a pound symbol on a line in Python, that means that it's a comment. It means you can say, hello, I'm a comment, or whatever. It means that the interpreter, and we'll go over what an interpreter is in a bit, the interpreter will just skip over this line. It'll just ignore it. It won't run, so this doesn't have to be computer code. You use this for titling different sections, saying, oh, this part of this code does this line is supposed to do whatever, so that when you come back to your own code later, or if you hand your code off to somebody else, they can figure out what's going on more easily. Or maybe it's late at night. I do this a lot. It's late at night and there's a little bug and you know what's broken, but you're not exactly sure how to fix it yet. You'll just say, like, I don't know, this is broken, fix it, or whatever, and then when you come back the next day, you just go to that comment and you say, oh, okay, yeah, this is where I need to pick up where I left off. So that's comments. Now to get into actual programming, we're going to talk about variables. So just as a very simple example, we're going to do x equals 2. What's happening here is we are declaring a variable, its name is x, setting it equal to the value of 2. In other languages, you have to end every line with a semicolon to indicate that that's the end of the line. You don't need to do that in Python. I think you can, it doesn't mind, but there's no reason to do that. Also, in a lot of other languages, you have to declare what type the variable is in front of it. So you'd have to do like int x. Now would be a good time to talk about data types. So there are a bajillion different data types, but we're only going to go over a few of the really common ones you're going to be using a lot. So 2 here is what's called an integer. X here is an integer. That just means basically it's a whole number, negative 37, 0, 12, whatever. It's a number. Next kind is called a float. This means that it's a number with a decimal. This here is called a floating point, so that's why this is called a float. It's important to know that there is a difference, and I'll get into why in a bit. Just for now, know that ints are whole numbers, floats have decimals. Next kind is a string. You see it's colorized differently. A string just means text. It's basically whatever you want. This could be somebody's name, it could be a file path. You see up here at the top, we're in my D drive, stuff, Python class, lesson 1, example.py. That's called a file path, or it's called a few different things. It's the path from whatever drive to whatever file you want. And when we start working with all different files, we're going to be working with these, and those are usually returned as a string. But it could also be instructions. If you're making a program for other people to use, you can write out instructions as strings. Just know that strings are text for now. And then the last one that we're going to go over in this section is a Boolean. So this means true, see how it's purple, or false. Those are the only two values a Boolean can be. This could be whether or not a mouse button is held down or a key on the keyboard is held down. You know, it's either down, which is true, or it's up, which is false, or whether or not something is a certain size or whatever. Well, Booleans are very, very useful, and we'll get into them later. Just a little theoretical stuff I want to go over, because this much of the theoretical is useful to know. Here we have x equals 2, and I should point out this isn't math. It doesn't have to be x. You could say my variable equals whatever. You can name variables whatever you want. I'm just keeping it x for simplicity. So we have x equals 2, and then down here we can say x equals 7, and then we can do x equals a string. And Python doesn't mind. This is fine. You know, the value of x here is going to be 2, and then it's going to change to 7, and then it's going to change to this string. Python is what's called dynamically typed. This means that a variable you make, you can change the type, you can change the value whenever you want. It's very convenient. You can think of it as we have a box, a cardboard box, and we're writing x on the side, and then we can put whatever the heck we want in that box. Other languages like C, for example, or Java, I think, you have to do int x equals 2, like I was writing earlier. And then if we tried to do this, it would throw an error, because not only are you writing x on the side of the box, you're writing what kind of thing, what data type is going in that box. So we're saying, alright, we have a box, we're going to put x on the side, only ints are going to go in that box. This would be okay, but then when we try to put a string in the int box, it would be very angry with us. And then also in C, from what I've heard, you don't just say the name of the variable and the kind of the variable, you also have to say how big the variable is going to be, how much memory it's going to take up. You have to do a lot of stuff manually. And that's one of the major differences between Python and things like C. C, you have to do a lot of stuff yourself. You have to do a lot of things manually, so it's much harder to read and write, much harder to learn. You can fine-tune things a bit better because you're doing everything yourself. Nothing is really automatic. You can make things more efficient, but in general, people seem to be moving towards Python because this is just, get rid of this. It's just so nice and easy to be able to do this. Now I want to get into the difference between integers and floats. So here we have x equals, we'll do 7, and then we'll do y equals 7.0. And then also, this is a print statement. So this means that whatever you put in here, and it has to be a string. Well, it doesn't have to be if it's just a number. Python will automatically convert it, but it's smart to convert it to a string first. And we'll talk about conversions in a bit. So here, let's do z equals x over 2. So that's going to be 7 divided by 2. And we'll do w equals y divided by 2. So that should also be 7 divided by 2. And then we're going to print z, and then we're going to print w. The print statement means that whatever you put in here is then going to be printed out in the console. So if I save, hit run, which I believe it's F7 by default, I hit build, you see in the console down here, we have 3 and 3.5. Of course, we know that 7 divided by 2 should be 3.5. It should be 3.5. The difference here is that 7 is an integer and 1 is a float. So an integer divided by an integer is always going to be an integer. So Python just rounds down to 3 to make it an integer, because it can't be 3.5. Whereas here, it's a float, so then a float divided by int can be a float. We get the proper answer, 3.5. You may think to yourself, okay, so then why wouldn't I just use floats all the time if integers sometimes give the wrong answer? We'll see probably in the next lesson that you have to use integers for certain things. If you're counting things, like if you have a list of stuff, you can't really, you can talk about the first thing in that list or the third thing in that list or whatever, but you can't say what is 2.5th element in that list. Like that doesn't, what does that mean? And then Python will get all confused. So that's the difference between integers and floats. Just a basic introduction. Something else I want to talk about, strings, working with strings. We'll say this is, and then y equals a string. We can put these together. It's called concatenating. So we're going to say this equals x plus y. So we have the variable x, setting it equal to this string, have the variable y, setting it equal to this string, and then we have the variable z, setting it equal to x plus y. So if we print z, and we hit run, this is a string. It put this together with this. It just kind of mushes them together. Something you need to be aware of, if we say, I don't know, I want so we were doing this, we wanted to say, I want 2 strings. And we're going to do w equals that, and then print w. So we're looking at this and we're saying, okay, we have I want, we have the number 2, blank string. So when we put it together like this, it should say I want 2 strings. But if we run it, we get an error. This is because, well, you can actually see it down here, and this is a good example of what happens when you're when you have an error in Sublime. This is the problem right here. Error cannot concatenate, and that's what it's called when you're mushing strings or other things together, concatenating. Cannot concatenate string and int objects. You can't just mush together a string and an int. So what we're going to do is convert this 2 to a string. In Python, you just do it like this. We'll go over all the conversions in a second. So this string function, it's built in with Python. You just do string or stir, and then whatever's in these parentheses, it doesn't matter what it was before, it'll get turned into a string. So save, and we run this. I want 2 strings. There you go. Some other conversions, we can do string of a Boolean. Do that, you just get true. That's fine. An interesting conversion that can be useful, you can convert a Boolean to an integer, in which case true maps to 1 and then false maps to 0. This can be useful for, you're setting the size of a window equal to the int of something, the int of a Boolean times whatever size it should be. So if that Boolean is false, the size is going to be 0, the window isn't going to be there. And then if this Boolean is true, it's going to be 1 times 500 pixels or whatever, and then the window will come up. So you can have whether or not a key is down, a key is pressed, linked to a Boolean, and then that can control whether or not a window is visible. So like you hold something down and something pops up, or something like that. We can make a float from an integer. So if we do float of 2 and we run it, oh, gotta print it. There you go, 2.0. See, we went from an integer to a float. One more thing while we're talking about, or well, second to last thing while we're talking about variables, is with strings, there's something called a break line. So we'll say hello, and then if you do \n, that's a break line, and you'll see what that is in a minute. My name is whatever. So a break line is just something that you stick in a string, and it makes it so when you're printing, it'll go onto a new line. So if we print X and we run it, forgot the equal sign. There we go. Hello, my name is Alan. There you go. You see how it broke up the string to be on each line. This is useful for if you're printing out instructions for an end user, but I find I'm using it more often with if you're reading an external file, if you're chugging through data from a lab or something like that, you're measuring something, and you try to read that line, each line will have this at the end. And if you're not expecting it, then it can cause errors, it can cause all kinds of problems, you won't know what's going on. This is one of those things, I'm not sure what this is called exactly. There are different ones, like \n is a break line, \b I think is a backspace, but that doesn't usually work in most contexts. The really important one is just know \n means break line. It means that it's going to print on a new line. Now the very last thing is another data type, the fifth data type, is the none type. So this is going to seem kind of abstract, but it'll make more sense later. It basically means X exists, the box that says X on the side exists, but there's nothing in it. There are different kinds of nothing, if that makes sense, in programming, and this is one kind of nothing. We'll see other kinds and how you can use them in a little bit. For now, just know that none is another data type. Also know that there are like dozens or hundreds of data types, but you'll never see or hear of most of them. We've only gone over 5 so far. And that's it. That's it for the variable section. One more thing about strings is nesting. So you usually denote a string with double quotes. We'll say this is called a, and then if you want to have quotes print out, you have single quotes. So we'll do string, and we'll print that. This is called a string. See the quotes show up. This is useful in instructions and stuff like the other things, but you just need to be aware that if you want to have quotes within quotes, this is how you want to do it. And if you then want to put like double quotes inside here, that causes problems, because you see Python looks at this and says, okay, here's a double quote, we're beginning the string, and then it sees it here, okay, we're ending the string, and then here we're beginning and ending, and then this stuff in here it thinks is a variable. It's just, this is just a big problem. So if you want to do this, you do \that. This is called an escape. Basically, it means that Python will see this, we're beginning a string with the double quotes, it's going on and on and on, and then it knows that this is not the end of the string. So we do this, and we print it. This is a string. You see the double quotes are still there. This is also important for if you're chugging through external files. You can download the files for a website and parse through those, and there will be quotes within quotes within quotes within quotes, and it's ridiculous. Just know that this is how you work with it. You have to escape them. So that's it for variables. Now we're going to talk about flow controls, starting with if statements. So all we've done so far is assign values to variables. We haven't actually done anything with those variables. So one of the very, very basic things you can do is we're going to make a variable. We'll do condition so that it's clear. I have a variable named condition. We're going to set it equal to the value of true. I'm going to go down here, and this is our if statement. If condition colon print it's true, and we're going to save and run that. We say it's true. So what's happening here is you have an if statement, so Python knows that you're making an if statement basically. And then whatever is in between that if statement and the colon, this needs to be a Boolean. So here we legit just set it equal to true, but I'll show you more complicated and useful examples in a bit. But whatever's in here needs to one way or another be true or false. If it's true, then whatever is indented here will run. So we can do x equals 2 or whatever. And then we go out here, run anyway. Save and print that, but we'll run it so you can see. Whatever is in here is only going to run if this condition is true. But then once it's called dedenting. You see we have an if statement, we indent. So this is the if statement block. And then we go back to the left, we dedent. This stuff is outside the if statement and it's going to run whether or not this stuff runs. So you can see if we make this false and we run it, this condition was false, so this code didn't run, but then this is outside the if statement, so this runs anyway. For a more interesting condition, we can do x equals 2. Now we're going to do if x equals 2. We'll put spaces for clarity. So what's happening here is one equal sign means you're assigning the value. You're putting something in that box. When you have the double equal sign, then you're basically converting this whole thing into a Boolean. We're saying if x is in fact, that's just how I read it in my head, if x is in fact equal to 2, then, the colon means then, do whatever. So save and run that. It's true because x is in fact equal to 2, so this runs and then this of course runs anyway. You can do greater than or equal to, you can do just less than, you can do all different things. Just to really drive the point home if anybody is confused, we can do print x equals 2. We'll run that. We get true. We get the Boolean true, because this is true. If we want to check if something is not equal, you do exclamation point equals 2. So if we run that, we get false. So that's what this does. It's you're comparing something to something else and making the whole thing a Boolean. So then we can use it in if statements. Something else. An example of the none type from before, we do x equals none, then we can just do if x, print it's true. So you see here, this part runs of course because it always does. This part does not, because this is the one time you can have something other than a Boolean. We're doing if, and then there is no Boolean here, there's just a variable name. So then we're saying if x exists, then print stuff. And we say, well, there's the box x, but there's nothing in it. We're saying if there's anything in the box labeled x, then run this. So if we do x equals 2, and run that, it's true, this exists. What I was saying before with the different kinds of nothing, if we just don't have an x there, we don't have a box labeled x, this would be, you say, okay, well, x doesn't exist, so everything should be fine, it's just this stuff doesn't run in here. But if we try to run it, we get an error, because name error, name x is not defined. So when you're checking for existence, you're checking to see whether x is none or not, whether or not the box is defined. So that's with existence. And that's useful because sometimes you'll be using built-in functions, you'll be checking if things exist, and you don't get to choose what you get back because you're checking. You're checking whether a window is open or whatever. You might get back an integer or something, some sort of variable, or you could get back none, and then you could use something like this, if x, to check whether or not you actually got something back. If x is going to be a Boolean, we'll do condition like we had before, equals true. If you want to invert something, you say if not. You see it colorizes that. We run that. This does not run because condition is true, so we're saying if not this, then do it, but it is, so it's not going to run. Just to show you what this not operator really does, do print that it's false. So by doing not, you're inverting whatever this is. If this was false, it would make it true. If it's true, it makes it false. So we have true, so then that makes it false. So that's the not. I guess it's called an operator. I don't really know. Something else we can do x equals true. I'm going to do y equals false. Remember to capitalize Booleans in Python. In other languages you don't. We're going to do if x or y. Then we're just going to get rid of this. It's true, it runs, because even though y is false, x is true. And we're just saying if either or. If one of these is true, then we're running. We can make this and, in which case it doesn't run, this doesn't print, because one of these is true but the other is false, and they both have to be true because we have and in order for the code to run. We can do something a little bit more interesting, or a little bit more useful, more complicated, we'll say. Else print false. So here we have expanded the functionality a bit, you could say. We're doing if x, so if whatever this is true or defined, print it's true. If this condition is not met and this doesn't run, then do this block. So that's saying try to run this block. If we can't because this is false, then do this. This is the default behavior, you could say. So if we run that, of course it's true because we set x equal to true. If we make it false, then this part runs, because if x is false, so no, go to the next thing. We can expand the functionality further. We can do elif print. Oh, let's do this. We're going to set x equal to 2. If x equals 2, do this. Elif x equals 3, do this. And if it's not 2 or 3, then we're just going to print what x is. 5, x is 2, so that runs. If we make x 3, this part runs. If we make it 378, or whatever, then this part runs. So this should be fairly straightforward. If this condition is met, then run this code. If that condition is not met, check if this one is met. And if it is, then do this. If neither of these conditions are met, then do this. Run whatever we put in here. And I've just been putting print statements and everything. We're going to get into much more complicated and useful stuff later. And another thing, you can put as many elifs as you want in here. So we do elif x equals 5 or whatever. And remember to have the indenting correct. You know, you do elif and then indent, dedent, indent, like that. One very last thing for if statements is something called a ternary operator. So this goes like this: equals a if condition, else b. This is just the syntax. I'll explain more in a second. So we're declaring a variable y, setting it equal to the end result of this. So y equals a if this condition, if not this condition, so if condition, else b, meaning y equals a if this, if not this, then y equals b. So we can do, I don't know, 3 and 7, make this x, and then we're going to print y, and we run it, we get 3. So y equals 3 if this is true, and we set it equal to true. If we make this false, then y is going to be 7. There you go, it's 7. So this is really useful for toggling things. You could do y equals false if y, else true. Set y equal to true, just to show you. Copy and paste that a few times. You see it toggles it. It starts off as true, saying y equals false if y currently equals true. If y doesn't equal true, make it true. So this takes whatever it is, it's true or false, and flips it. If it's true, makes it false. If it's false, makes it true. And then we're printing it, and then do that again, and we're printing it, do that again, and we're printing it. So you can see we start with true, and then we get false, true, false. So this is useful if in your program you have somebody pushing a key, and each time you press it, you turn something on and off. Some sort of functionality, or you're changing the shape of something, whether or not something's visible, whatever. If you have two states that you're cycling through, ternary operators are very nice. It's just simple, one line, not very complicated. It's efficient. So last thing for this lesson, if statements are one kind of flow control, another one is loops. There are two main kinds of loops. Before we get into that, we're going to talk about one more kind of data type, which is a list. So I'm going to say my list, declaring a variable, calling it my list, and then with square brackets, we're going to do just a whole bunch of junk. A list is a whole bunch of variables or variable values or whatever separated by commas. And we can do like x equals 3 and then place these with variables. So you can see you can mix and match, you can do whatever you want. It's just a list of stuff. This could be a list of files that you're going through, you're cycling through. It could be buttons on a screen, you want to change them all to be blue or whatever. You want to change the color, you want to say the text that's on them. It's just a list of stuff, whatever that happens to be at the time. So if you want to access specific things in this list, we can do equals my list, and then in square brackets the number of whatever we want. So it's important to know that with lists and with pretty much every programming language, I think except MATLAB, we start at 0. So this is number 0, this is number 1, this is 2, and then this is 3. So there are 4 items, and the last thing is 3, is number 3. If it helps you remember, I intentionally made it so that this video series starts at 0. So this is lesson number 1, even though it's the second in the series. So if we do my list 3, and we print z, we get 5.6. So that's that. If you want to swap things out in the list, we can do my list 3 equals 12 27, 2.7, whatever. And then we can actually print the whole list if we want. And again, we should be converting everything to strings, but in this case it's okay. So here's the list. The list started off as this, and then we took the third element in the list. We don't care what it originally was, we're making it this. And then we're printing the whole list. So you can see the last thing went from being 5.6 to 2.7. So it's called indexing, what we're doing with these square brackets at the end of the name of the list. Now, if we want to cycle through stuff, we do, this is the first kind of loop. There are two kinds of loops. For, we'll do element in my list, print element, and we hit F5. Well, I hit F5, and there you go. What's happening here is we have this list, we have these elements. For element, this is a new variable name. The whole point of the for loop is that the value of this variable is going to equal this thing, and then this thing, and then this thing, and then this thing, for however many elements there are in the list. In this case, we're just printing each element, but we could do like this is 3. We're just going to make them all integers. Make this 7. Make this 1. Print element -1. And we run that. So element equals 3. Subtract 1 from it, and print it. This is called nesting, by the way. We're doing some stuff. We're subtracting 1 from the value of element, and we're printing it all in one line. So element equals 3, subtract 1 from it, and print it. We get 2, because 3 minus 1 is 2. And that's the end of the code block. In this case, the code block in the for loop is just this print statement. So end of the code block, we start back up at the top. Element now equals 5. 5 minus 1 is 4. Print that, we get 4, and so on throughout the list. This could be a list of file names, like I was saying, or buttons. So then instead of just a print statement, this could be the functionality to change the color of the buttons, or open files and read files, or whatever. There's a jillion different things you can do with this. For loops are very central. For loops and if statements are like the two most basic things. You can do a for loop that's not looping through a list. For example, we can just get rid of this list, and we can do for x in range. We'll do from 3 to 8 or whatever. Well, this sort of is a list. Here, you'll see. Save that and run it. The range function makes a list where it's like that list we just had, where it's a list of integers from this to this, but not including the very last one. So you can see here we're looping through that. We're just printing each element in the list. 3, 4, 5, 6, 7, and then it doesn't do 8. And there are all different things. There's like x range is a different function. There's all different things. This is just the one that I use a lot. Something else, if we do have a list, just undid a bunch. In other languages, you would do for I equals 0. This is JavaScript, just so you can see. I less than 10, I plus plus. Here, I forgot the colons, or the parentheses. That. This is not Python, what I just wrote. This is JavaScript. just so you can see. Here we would be setting a variable I equal to 0, and then we're adding 1 to that variable as long as I is less than 10. And then we could do like print my list I. So in Python, the iterator, you can say, is actually the value of the thing in the list. It's actually the value of the element. Whereas in most other languages, the iterator is just a number. And then if you want the element in the list, you have to do my list and then I or whatever. If you want that I in Python, you do for I, comma, whatever you want to call it, in, and then here we do enumerate that. And then, so you can see what's happening. Element number. Here we're going to have to do a conversion. Put a space here. Put a space here, and this needs to be converted to a string too, actually. We're concatenating a whole bunch of strings. We'll run that. So there you go. I element and enumerate my list. Enumerate basically makes this list a list of what are called tuples. A tuple is in itself basically a list, but it only has 2 values in it, like strictly 2 values. So what's happening is I equals 0, element equals, in this case, 3. And then we're printing all this. You can see the result of this here. It should be pretty easy to follow how we're getting from this to each of these lines. I equals 0, element equals 3, and then I equals 1, element equals 5, I equals 2, and then element is going to be 7. And remember, these don't have to be integers, they can be strings, they can be booleans or whatever. So that's if you want to keep track of which entry in the list you're in. Most of the time you don't care, but if you do care because you want to say something like, is number 0 in my list, or number 2 in my list, or whatever, this is how you do it. You use enumerate. That's about it for for loops. The next kind of loop is a while loop. So we'll just get rid of everything. Next kind of loop is a while loop. So we're going to set a variable I equals 0, and then while I is less than 10, print I, and then I equals I plus 1. We'll run that. So what's happening here is setting a variable I equal to the value of 0, and then while I is less than 10, do this code block, we're printing I, and then I equals whatever the value of I originally was, plus 1. So here we're printing I is 0, and then we're making I 1. Print 1, I equals 2, print 2, I equals 3, print 3, I equals 3, and so forth. This is a Boolean, you'll remember from if statements. By having this less than sign, we're making this whole thing a Boolean. So the way while loops work is while this condition is true, and you can actually just do, there are times where you'll have a while loop that's just while true, do whatever. While this condition is true, one way or another, run this code block. And then eventually I is going to equal 10, in which case it's not less than 10. This is going to be false. This while loop is going to, it's called breaking. You break out of the while loop, and then like if we did something down here, then that would run when the while loop was done. While loops are, from what I understand, not as fast as for loops. You can do the same thing with either one. You can iterate through lists and stuff with a while loop, same as you can with a for loop. And while loops are not as fast, but they are more efficient, sort of. Like your computer processor can run it more easily than a for loop. Little fun fact I find interesting. NASA, I've heard, has actually banned while loops within themselves. So even though while loops are easier to run, it's easier for a computer in space to run a while loop, they have banned them because if we forgot to put this here, just for example, just comment it out, then I is always going to be less than 10. Because I is never changing. I starts off as 0, and then without this, I is never changing. So, actually I can print this. You can see it's just printing 0 forever, which is bad, because then whatever code after this will never run. And some systems you can crash it, or whatever, you can damage stuff. It's something that you don't want happening while you're in space. And this will probably happen to you at some point if you're using while loops. You'll forget to do something, so then this condition you're expecting to be false at some point, it never becomes false, it's always true, and then your code gets stuck. Now, if you want to do what we were doing with for loops with a list, we're going to just say here my list, and remember you can name it whatever you want. Hello. Whatever strings. We do while I is less than, here's another built-in function, len, which means the length of whatever we put in here, whatever list. So this is saying while I is less than the length of my list, in which case this is 3. Print, do my list, the ith element in my list. We'll get rid of this. Run that. Hello string name. There you go. So yeah, just know that len of whatever list is going to be the length of that. You can also put a string in here, so like len of hello is going to be 5. So there you go. You have flow control, you have the loops, you have if statements, you have variables. You could write a very basic program right now. And that's it for the first lesson. Thank you for watching. I hope you found this informative and helpful, and I hope you enjoy the rest of the series as well.